It's my honor and pleasure to introduce to you our keynote speaker for the day, a leader in the field, Wendy Nather, strategist, research director, former industry analyst, and former CISO, so she's been through the ringer, right? 30 years of technical experience in IT operations and security, including 12 years in the financial services industry and 5 years in state government. Let's get a big round of applause for Wendy Nather. Thanks. There you go.
Very much. Thank you, Rich. Thanks to everybody for coming today. Yes, I've been through the ringer in security, and now I've been through the ringer in LA traffic, so I have seen it all. I was really excited when Rich put up the image of the Disney castle from Euro Disney, and I didn't realize I had that in common with him. Speaking of pushing past your comfort zone, when I was working for a private options trading firm in Chicago, we were acquired by a Swiss bank. And since I knew French and German from my liberal arts background, and I spoke Unix, the three important languages in a Swiss bank, I volunteered to move to Zurich to be part of and to lead their Unix system administration team. So I actually did administer those Spark stations as well as Next cubes. And talk about pushing past your comfort zone. That was interesting. But that got me into security because, of course, when you're working for a Swiss bank, you have to care a whole lot about that. And I just happened to be in Europe, in Zurich, at the time when Euro Disney opened. So I was really excited, and I went there. I have a picture of myself in front of that castle, so I'm now excited to know an architect who worked on that. That was just so cool. Where did Rich go? He left. He left. I'm like, I'm done. He's at the beach. Yes, yes, as we should all be. So let me see if those are not my slides. I'm going to have to improvise based on the YouTube. This is going to be like PowerPoint karaoke, where I'm just like, well, obviously we're going up and to the right, as every good security vendor should do. So my name is, as Rich said, I'm Wendy Nather. I lead the advisory CISO team at Duo Security, which is now part of Cisco. So Duo, Cisco, I guess you could just call us Disco. And I do want to thank Rich for inviting me today. He was really persistent about it, like over the past year. I guess those of you who know Rich know that he's very, very driven. So I am going to talk about YOLO, and I co-opted this term because I really love annoying my teenagers by misusing slang terms. Because really, if you can't amuse yourself at the expense of your kids, what's the point in having them? Well, okay, also spare parts, that's another reason to have kids. Child labor, but anyway, I'm really digressing. I'm going to talk about authentication in the age of cloud. But first, let's talk about what authentication is. Authentication is not the same as identity. Identity is really it's hard. It is the overlay through which the business accesses IT. And because business is so complex, that's why identity is so complex. It's very, very hard to do. It's like, you know, okay, you are Jeremiah Grossman. Great. Good for you. Good for you. Why do we care? It's not that. We need to know why we care that you are Jeremiah Grossman. And it's because you are the founder of this company. Okay, now we know why we should care that you are who you say you are, therefore you should have access to these sorts of things. So it's not identity, and it's not authorization either, because authorization is, yes, you know, we set this up for you because you are Jeremiah Grossman, therefore you get these entitlements, you get access to these things. So this is everything that gets set up before you start using anything. Authentication is about what happens after you're set up, And it's the real-time re-verification that you should be accessing this stuff. It's like the DMV gives you your driver's license, that's your identity, but the bartender is going to check your ID when you ask for an alcoholic drink, and that is, that's authentication. So are we all on the same page on that? Okay. So what's the main question we're asking when we're trying to do authentication? The main question is, what is the risk if you should turn out to be the wrong person who is authenticating for this session, who wants to use this session? Because a sufficiently successful attacker looks exactly like the authorized user. I heard a great story about an attack where they compromised the credentials of a system administrator, and they came in from the sysadmin's home machine, which is what you would expect a sysadmin to do, remote support. They came in through the VPN, which again you would expect to see. They went straight to the domain controller, which again you would expect a system administrator to do. The only difference was that they had changed the keyboard to Chinese. That is the only way that they figured out that it was not the system administrator. So this is the very, very big challenge that we are trying to address with authentication. And the other question that we asked during that session is, what is the risk if you're not alone? Now, there's a lot of marketing out there for security, and a lot of it is very FUD-based, and I don't want to scare anybody, and I was trying to come up with a nice image for what is the risk if somebody else is coming in with you in this session, if they've compromised your machine, if they're using your machine to come in. And so the only thing I could come up with that was not hoodies or baklavas or anything like that was a conga line. So what if you are, in a conga line coming into your session, to your application, and you've got a lot of friends with you? And the point is that from a risk perspective, we're saying, no, don't bring your friends. Ethel always drinks all the beer. Don't bring Ethel. We don't want anybody but you coming in, which is why we do a lot of things like inspecting devices and things like that. So those are the two questions we ask ourselves in doing authentication. Are you the same person we gave the account to at this time, and are you alone? So there are a lot of security approaches that have been trying to address these sorts of issues. It used to be that we would just, rely on IP addressing and things like that for part of the authentication. And we knew that this wasn't a good idea. And so early on, in the early 2000s, a bunch of financial industry CISOs in the UK formed the Jericho Forum, which is named after the walls tumbling down. And they first discussed the idea of deperimeterization, of saying we might as well just assume and pretend that everything is directly on the internet because we can't trust what we're using right now to authenticate. And that was a great idea. I remember as a CISO looking at that and going, well, they're absolutely right, but I have no idea how I would implement this. The other problem that I think we had with deperimeterization is it's really hard to say after a couple of pints of beer. I think that's why it did not catch on. It's just too hard. So John Kindervag, when he was an analyst at Forrester, came up with the term zero trust, and that's much easier to say at 3 in the morning. Zero trust. I can say that too. So I think that's why that has picked up as, as the slogan. Who here has already heard of zero trust? Who is already tired of hearing about zero trust? Yes, and I know. Even inside my own company, when I start talking about it, there are people that go, oh. Yes, it is the new buzzword. I think that this is the discussion we're going to have around zero trust is the same that we had around cloud when it first came out. You remember when we were all arguing about what cloud really was? That's not cloud. This is cloud. This is a zero trust printer. No, that's not how zero trust works. Well, I guess it does if you're on a Novell network, but anyway. So we talked about you really shouldn't, start by trusting anything, and then Google adopted this design pattern and implemented it within their network. It took about 7 years, whole bunches of engineers, a lot of money. They wrote some really good white papers. I think there are like 6 of them now on how they did their zero trust implementation, which they called Beyond Corp. Intel also came out with a similar architecture. called Beyond the Edge. So, Beyond Corp, Beyond the Edge. You can sense a theme here. And Gartner, of course, introduced their version because, and I know as having worked as an industry analyst, you always have to make up your own buzzwords. You cannot use the competition's buzzwords for something. So Gartner came up with CARTA. They couldn't use the term zero trust. So there's all this fighting around what this means. But what we generally all, talk about, and I'll talk more about zero trust, but, we all sort of understand it when we see it. It's a response to the problem that, cloud and mobile have made authentication harder. And one of the big reasons is that we have been using location as a proxy, as an assumption, a component of trust in a lot of different ways. So there is... Back when I was first learning programming, which was in 45, in the Pleistocene era, in 1974, when I was learning programming, there was just the one way to access a computer. There was just the mainframe. There was a hardwired terminal. First of all, not everybody wanted to access the mainframe. So, you were already self-selecting if you sat down in front of the terminal and, you had a reason for being there. We would assume that you had physical access to the building, to the office. You had a key to the office. We assumed that if you had the key, you were sort of authenticated that way, so you were a person who was supposed to have access to the mainframe. You had the business legitimacy, you had the reason, and also if you even had the knowledge to do it, we assumed implicitly that you were supposed to get that access, that you knew what you were doing. And this was all, and you were previously vetted as somebody, checked you, let you in the building, checked your ID. We assumed all of this as a component of location because the location was static. So we all assumed this as part of the authentication, as part of the trust. But of course, that's changed now. We are now, everybody for any reason can access computing resources from anywhere with devices that were not necessarily issued to them by their corporation. And they can be anywhere, and the applications can be anywhere. So all of that has just exploded, the notion of location as trust. So how do we address the risks? Now remember, we've been talking about all of these different terms, which are kind of the same and kind of pretty much, they're pretty much the same. What does zero trust really mean? And this is where I get into knockdown, drag-out fights with John Kindervag at Forrester, because I think that there's a semantic difference in how he describes it. There are a lot of people who don't like the term zero trust, and I can't say as how I blame them. Because you cannot walk into a room, especially management, and say, we're not going to trust anything or anybody because we're going to do zero trust. That's not how business operates. So it's a difficult, fraught term, but let's explore it a little bit. I think we can all agree that it kind of means don't trust something just because it's on the inside of your firewall, for the reason of, insider access, for the reason that IPs can be spoofed, all the different reasons why we know this doesn't work. I think we start with this very fundamental principle. Just don't trust something just because it's on the inside of your firewall. Now, where I differ from Kindervag is that the word trust can also be kind of slippery. You can say that trust means granting access without verifying, which I agree you should never do. So, never trust anything, always verify everything first. Or you can say that trust means granting access because you verified them, which is why you're going to hear, other vendors, including Cisco, describing trusted access. We trust because we verified. So you're going to hear that big distinction, but try not to let it get too confusing because we're still all agreed on the basic principle of don't trust something just because. Now, here's an analogy I like to use. I'm always looking for better analogies, so if you can come up with one, let me know. Let's say that this room is a club, and we've got somebody at the back who is the bouncer, and they're like the firewall. Now, they will let people in for a bunch of different reasons, but if you come up to me as the bartender and you say, I would like an alcoholic drink, I will say, look, I don't care why the bouncer let you in. If you want to access my service, you're going to have to show me some ID, because that's my security policy. So you're pulling back a lot of the expression, the enforcement of security policy right back to the application itself, rather than enforcing everything at what used to be the classic network perimeter instead of the firewall. Because, you know, maybe I'm the bartender and I'm out by the pool and you never ever saw the bouncer, which is pretty much what SaaS is, right? So if you come in, if you want to access the nacho table, you don't have to show ID. We don't care about that. If you want to access alcoholic beverages, that's a different service. That's more confidential. That's more sensitive. I'm going to need to see additional ID, and I'm going to need to authenticate again for other reasons. Now, that doesn't mean that I should be showing your ID to everybody else in the club. We don't need to be spreading the identity. We just want to do the authentication where it makes sense at the point of access. So does this resonate with people? It resonates a lot with my salespeople. I don't know why. It's a mystery. But you know, if you can think of other ways to describe this, let me know, because I think this is easier than just saying never trust anything. You know, we're discussing why we trust, when we trust, and for how long. So in theory, it should not matter where they are or where the app is. They should get the same checks regardless. That's the basic, you know, principle here that we're trying to do. So here's Google's Beyond Corp model, and I won't make you stare at it for too long, but I just want to point out some of the common elements in here. They have a centralized access proxy, which you have to hit no matter where you're coming in from, whether it's a public network, whether it's a Google network. You've got to go through the access proxy. They are making access decisions based on a bunch of information, a bunch of data that they have on the security state of whatever you're using to access it. So they have an asset inventory, you know, they have logs, they have information about the last known security state of the device you're using. And they have information on the sensitivity of the resource that you're trying to access and the business rules associated with it, and they make the decision there. But the whole point is it shouldn't matter where you are or where the resources are. They're making you go through the same process. And Intel, as I mentioned, did the same thing with their Beyond the Edge. Again, a centralized access proxy and information on the security state. You're going to see different things based on which identity providers you're using at which points. And, you know, I'm not going to talk about that because, again, that's the most complex part. A lot of the enterprises that I talk to, you know, that's the most difficult part of deciding what information to feed into these access decisions. But what we want to do is figure out, are you the right user? Are you the one that we actually gave the account to? And so you need to choose your factors. How are we going to figure out whether right now you are the right user? So that you've seen this. This is the classic set of something you know or something you have, something you are, biometrics. Or in my case, as you get older, it's something you forgot, something you lost, or something that aged. I don't know about you, but my biometrics change every morning when I get up. Gait analysis is not going to work for me because depending on which hotel bed I slept in, I'm going to be walking differently. But this is what we are all, you know, trying to figure out as we're building our authentication design. I do not recommend blood samples as part of biometric authentication. This is University of Michigan, very funny folks. There are a lot of people, especially students in higher ed, that do not like having multi-factor authentication. So this was from one of their parody websites, and we're like, okay, let's go with it. Sure. Why not? Yeah, like, here you go. Everybody take some. So again, we're going to ask, you know, not just are you the user, what factors are we going to figure out here, but are you alone? Are you in the Congo line? Let's check the device. What are we going to check about the device? Now, you can either Check that, it has been compromised or not compromised, or at the very least, check the security hygiene of it and say, is it likely to have been compromised in the time since we last saw you? So you may want to enforce things like, does it have screen lock enabled? Is it rooted? Is it jailbroken? Is the disk encrypted? Is it up to date on its software? That sort of thing, so that you can kind of make a risk decision as to, yeah, they're probably okay, they're probably not, not being accompanied by anything nasty as they're accessing the application today. So you have to decide what those risks are and how many factors you want to use based on what they're trying to access, because you don't want to use too many. The other problem, I think a fundamental problem with talking about zero trust, is that trust is neither binary nor permanent. So, if you're going to trust me, you're not going to trust me all the way to do anything and everything. My salespeople trust me to get up here and talk to you, but they do not trust me to do a duo deployment because I tend to break things. So you have to decide what you're being trusted to do. And that was the problem with the classic network perimeter, is we would say, okay, you're coming from the right IP address, you're coming in on the right port, good, have fun, go do your thing, and then you wouldn't check them later on. And yes, segmentation is a thing, but it is very hard to do inside of a network, especially a legacy network. It's really hard to figure out how to do. So, you don't want it to be binary, and you don't want it to be permanent. So for how long are you going to trust the user? And at what point do you think that trust has degraded enough that you need to re-verify the factors? So these are the things that we think about when we're thinking about designing authentication. And then in the middle of the session, we want to say, are you still the right user? Maybe we were wrong when we let you in originally. We thought you were you, but you're acting kind of weird, so we're not really sure that you're you anymore. Or you are now doing something that we want to make really absolutely sure. So we want to do some step-up authentication. We want to throw up, something else in the middle of your session, or make you re-authenticate at that point. And that's, again, something you would decide in the context of the application itself. Are you about to do a tricky financial transaction? Are you about to delete something really important? All right, let's verify again. This is where behavioral analytics would come in. That's where you'd put that in the mix. Now, here are some challenges that we've seen with implementing this sort of design pattern, with implementing zero trust. Part of it is translating that theory into applied changes. Like, this is a great principle, but again, how do we do it? I think the other difference is that now, compared to when the Jericho Forum came up with it, we have a lot more technology available to try to address this problem. Scoping the cost and the effort for management buy-in, you always have to tell them how much it's going to cost. And it's hard to know. I mean, you can find out from Google how much they spent, but that's really scary. So figuring out how you're going to do it, how much you're going to do concretely, and what that is going to cost can be difficult. There are usually separate organizations for every platform and technology in an enterprise. Some people call them silos, or as I like to call them, cylinders of excellence. You just want to, bring those together, because when you're implementing a consistent level of authentication across platforms, you're going to have to say, well, this is a mobile thing. We're going to have to wait for the mobile folks, to do their part of it. We're going to have to wait for the application folks to do these separate, things to implement the authentication. We're going to have to figure out, the criticality. So all of these things, that's often hard for an organization to start thinking horizontally across all of these different departments, because they've been used to doing it separately. Reverse engineering your current policies, figuring out what did we assume at the time when we first implemented this, and are those assumptions still valid? What are we thinking about? What did we assume, and is that wrong? Is that now a false assumption? So reverse engineering those when you look at how your current system is architected and going, why did we do this? Who thought this was a good idea? which, by the way, I would really love it if every tool I'd had as a CISO had some annotation functionality right at the point where you do the configuration. Because, you know, first of all, I would look at a firewall rule or something and go, who in the world thought that was a good idea? Oh, that was me. That was me 2 months ago. Or putting a notice in there so when the auditor's looking over your shoulder, you go, yes, I know this is bad, but we are going to fix this in June when we do the update on this other thing. And yes, this is the person who signed off on it. So having it all in one place would be really nice. I personally would love that. So being able to reverse engineer everything and then design it for the next phase. Say, if we start out by not trusting anything and we want to start fresh with a clean slate of factors, what would we want to put in there? And then finally, keeping it incremental and not radical, because if you go and say digital transformation to your management, you know, they're going to assume that it's going to cost a huge amount of money, and they're going to get really scared. But if you say we want to make security incrementally better, then they're more likely to buy into it. So let's just start with, let's do a few areas where you could start doing this. So if you wanted to implement something where you are authenticating your users more strongly, and I normally would not recommend this, but just as a thought experiment, let's just try this. If you were implementing 2FA for your users, and you registered all of them, and you only did the 2FA one time, and then you remembered their devices forever, if you did that, you would still have shrunk the attack surface, right? Because at least, you know, they would never have to 2FA again as long as they were using that same device, but you would be blocking out all the Mirai botnets and, you know, every other attacker that's trying to do, you know, is trying to use stolen credentials for account takeovers. They would hit the 2FA because they wouldn't be coming from the same device. So you've already shrunk the attack surface, and again, I'm not recommending this, but you could if you wanted to. Just do it, just remember all their devices forever, and you would have made things incrementally better. Level 2 is figuring out discovery, figuring out what devices your users are actually using to access your applications. Because you may think you know what you issued to them, but that may not be the case. This is our director of diversity and inclusion, Trey Boynton. She's magic, as you can tell. Asset discovery is really hard. I know Jeremiah will agree with me. Asset discovery is really a lot harder than it sounds. We had one organization that thought that they had issued about 800 corporate devices to the users. They put up something in front of their main application, and they discovered that there were about 2,000 or 3,000 other devices that were being used to access the applications that they didn't even know about. So, you know, unless you are enforcing things with something like, you know, a client-side client-side VPN or, you know, something like that, you really don't know what they're actually using. The other thing is that if you had third-party providers where you cannot issue and manage their devices, you're stuck with whatever they're using. If you've got a Deloitte contractor, they're not going to let you manage their laptop, but you at least want to know what they're using and how it's configured. So discovery is another really good step on that road. If you just do that discovery and start categorizing what you see, then you're taking another step. So you can look at things and mark them as, you know, we trust these more because they're corporate owned and they're corporate managed and they're monitored. We have a better handle on their security state, so we're going to trust them more. Or the ones that are coming from the consultants, we don't manage them, but we at least know that we're going to see them. Personal devices, like my personal phone, you know, Duo knows that that's my phone, it's only my phone, and they expect to see it. So you can mark it as trusted because it's known. That's very different from everything else that you've never seen before and or is unmanaged. So again, you know, if you have a closed circuit TV that is trying to log in with, you know, a set of your enterprise credentials, you know, this is probably not something that we want to let in. So again, incremental improvement, just putting another fence around what is being used. So you can go even further and bind users to their known devices so that, you know, let's say you have a fleet of 500 machines, that are all authorized to be on your network, but you can bind them to individual users. So even if you stole my credentials and even if you stole my second factor, you'd also have to steal my laptop, because if you stole a different corporate laptop, it wouldn't work because it's not my laptop. So again, you're narrowing the attack surface some more. You've got to get all three things in order to make the credentials work. And that's tricky because, as you know, user credentials can be silently stolen and copied and nobody will ever notice. If you start stealing physical devices, like 2 of them, somebody's going to notice. So again, you're making it harder for the attacker to get and make use of those credentials because they have to get so much else that goes with them. So this can also be an additional lightweight fence, besides your IP addresses. And, if you're using MAC addresses, that's fine. You got to keep using them. Just don't make them the only thing that you're using anymore. You can have an additional lightweight fence of the devices, the known devices. Level 4, if you want to get really ambitious on this, it's not that ambitious, but you can start enforcing security policies by simply saying, if you have that visibility into the endpoint, you can say, look, do what you want with your phone on your own time, but if you want to come into our application, you got to be this tall. You have to meet our security policies. So this is very useful, again, if you have third parties. We have a lot of healthcare organizations that have doctors that work for a lot of different hospitals, and each of them wants to put an MDM on that doctor's phone. And you can't have dueling MDM agents. That doesn't work too well. So if you can simply look at it with this visibility from a distance and say, we know that you are not up to date, and we know that there are some exploits that will be patched with the latest software update. We would really appreciate it if you would update to this, because otherwise we're not letting you in. And that can be very useful as well. It's a more collaborative way of dealing with your users. It used to be, very hierarchical. A corporation, we would, issue you your stuff. We would manage it for you. We would decide on Patch Tuesday that we were going to reboot your machine whether you liked it or not. But it makes such a huge difference if you've got users who are, can update. Let's say they have a grace period of 2 weeks. You got 2 weeks to update to the new OS version. They can do it when they want to. In our company, we have fleets of mostly Macs and Chromebooks, and we find that when we, set up the policy and say you've got 2 weeks to update, most of the Chromebook users update right away. Most of the Mac users wait until the very last minute before they update. And why? It's because it takes a frickin' half an hour to update a Mac. So, these are the sorts of things where if you can let the user have more control over that process, they're going to be a lot happier about it. But this way, you can enforce hygiene on endpoints that you don't manage. So this is the next step up when you're getting to that little zero trust nirvana. You can decide a lot of different things on those policies. We have some that there's not a lot they can enforce, but can we all agree that, jailbroken and rooted phones are not good? Can we at least agree on that? Good. Let's enforce that policy. So you can start enforcing policies bit by bit. The other cool thing is you can kind of use this as a poor man's incident response tool. Because if you know of something that's just come out and is being actively exploited, you can narrow the window, the grace period, in which your users have to update. It's happened that, we've seen something really bad come out, and Duo has said to us, we know we usually give you 2 weeks, but right now this is so bad we're giving you 3 days. Everybody has to update in 3 days. Or you can just lock everybody out of the application until they update, if it's really that serious. Now, again, that depends on what your users are willing to put up with, but it is an option that you have. And you need to be able to manage exceptions, because for every policy, there's an equal and opposite exception. I'm sure everybody has really cranky users, really senior users, CEOs, doctors, professors. It's my grant money, I'll do what I want with it, that sort of thing. So you are going to have exceptions that you have to manage for this. And even though enforcing by geo and by IP address is kind of antithetical to zero trust, if you have to do it, you have to do it. If you are dealing with data privacy issues, in other countries, yes, you do have to enforce geos. So, go ahead and do that. But again, don't make it the only thing, because those are too difficult. When I was working for the Swiss bank in the mid-90s, we were trying GPS-based access control, and it didn't work very well. You had to hold the transmitter out the window, or the receiver out the window, and it didn't work very well. Now, though, we have much better technology for that. So there are ways that you can do that as part of your zero trust strategy. And then finally, if you get to nirvana, you're doing this for every application everywhere, which, theoretically could kind of make the network irrelevant. And this is sort of the idea that you want to think about. I know, one CISO who told me that there were some applications where he didn't care if the user came in with what he called a dirty device or across a dirty network. He didn't care because it was just the cafeteria menu. But for ERP, he wanted them to come in over a clean network using a clean device. So you can make those distinctions as well. But for your users, for your third parties that only have to access one application, and it's not that important, or it is, but you have to use a hands-off approach to managing the security risk, these are a lot more choices that you can use now thanks to this model. And you get a consistent user experience, which is really, the most important thing. This is what we really want to see, so that your user doesn't have to care where the application is or where they are. Oh, I have to do it this way. Oh, wait, no, I have to fire up the VPN. Yeah. You want them to be able to go through the same things every time, and you want to be able to do, all sorts of things. Because fundamentally, you could think of the new perimeters being any place where you make an access control decision. Any place. So that means that you can and you probably should do it on different layers. So you can make access control decisions at the network layer, the operating system layer, the application layer, identity layer. When I log into Gmail, I can log in as my personal account, and Duo doesn't care about what I do. If I log in as Wendy@duo.com into Gmail, then Duo cares a whole lot, because I'm accessing Duo corporate data. And so Gmail says, oh, I see you're logging in as being with Duo. We're going to throw you over there, and they're going to do a whole bunch more checks on your device and everything. They have a lot more to say at that point. But the only difference is which login name I typed into the field. That's where the perimeter is at that point. And that's why some people say identity is the new perimeter. I don't think that's the case for everything. But I think it's a good argument for where you're making your access control decisions. So think about this when you're designing this. Where are you really making the decision, and what does that say about the decision that you're making? What are you basing it on? This is a chart by Sunil Yu at Bank of America. He's their chief security scientist. And I apologize if you can't really read it, but it's a matrix of talking about all the different authentication opportunities there are from different layers, from different entities to different entities. So if your device is authenticating to another device, you might use SSH certificates to do that. If your device is authenticating to an app, you might use a client-side certificate. If a device is authenticating to the network, that's NAC, and so on. Can anybody see what the issue is, though, with this sort of matrix? You can see all the different ways and all the different opportunities you have for authentication events. And yes, some of these are blank. I don't know if we've actually solved some of these combinations yet. Anybody have an idea what's wrong with this? The difference is, if you make your user authenticate all the time, they're going to get very cranky. Yes, we have the opportunity to have a user authenticate to the device, to the app, to the network, to the data. They don't like that at all. That's a big problem. Now, if you're talking about workloads authenticating to workloads, or devices like IoT devices authenticating to the network, you can do it as much as you want and they don't care. But your users care a whole lot. And that's why I think we have to design a very different experience and a different authentication flow for users, just because they hate this stuff. They really do. We have, in higher ed, we have the students who are very cranky about 2FA, as I mentioned. Some of them actually sit down and write an app to auto-approve Duo pushes so that they don't have to deal with it, and then they publish it. And we always look at it and go, should we try to hire them now, or should we wait until they graduate? I mean, they really don't appreciate that. So we do have to be very mindful of how we design the Zero Trust when we're taking users into account. However, WebAuthn to the rescue. Who's heard of WebAuthn? A few people? Okay, so this is a new standard in process that's being worked on, which is basically using asymmetrical key encryption to do the authentication. And we've had this for a long time. The difference is now that we have better ways of, first of all, protecting the key pairs and scoping it and making it more user-friendly. So right now, we have more opportunities to use something like a hardware security module to store the private keys, where we didn't have to depend on the user to protect it with a password, which could just, be easily read or stolen. It's really great when you have this set up so that you can use biometric authentication to authenticate to the HSM, and then from there, it takes care of the rest of it for you. It is scoped. The key pair that's being used for authentication is only being used per web application. So, you don't get all of that user's access even if you happen to get one key pair. And it's attested. So, we've done attestation before, but again, we've worked out better ways to do it. They're still working on it for consumer consumption because that's a little bit different from enterprise. But we are starting to get in a way that we can do this so that we are hiding a lot of the authentication foo-for-raw, that's a technical term, foo-for-raw, from the users. So this is kind of how it works, very simplified, where you're wanting to sign in and the site is saying, here's a blob of data. Please sign it with your private key so that I know it's you. And it automatically signs it and sends it back and goes, okay, it's you, come on in. And again, most of this is hidden, which is something that we've, public and private key encryption has been great. It's been so hard to use that even Phil Zimmerman doesn't want to use it anymore. It's very sad. So we are making progress on this, though, which leads us to the YOLO part of it, where we only really want them to have to log in once. That would be ideal. And yeah, YOLO, you only log in once. What we need is single sign-on for our users, but we need the authentication factors that are geared to that sensitivity level, which means that if we can corral all of these things, you shouldn't have to authenticate again and again just because you're going to a different application. You should be able to say the first application should be able, or the second application should be able to ask the first one, what have you already checked? This was 2 hours ago. And the other app can say, well, as of 2 hours ago, they were all up to date on their software, and you can say, yeah, that's good enough for me. We don't have to do this check again. So you could pass on what you've already checked and only add what you needed to if you were stepping up in terms of confidentiality. That would be ideal. And hide what you can, which is where WebAuthn and other similar techniques are coming in. So we want to be able to check what we need to, but hide as much as we can, pass on what we can, what we know about the user, and in a way that is attestable, that we can trust. So easy, right? Yeah, we're done here. Okay, let's go drink at the pool. But the most important thing is to keep your users happy, because that is, what really this is all about. This is why we're all here, right? Keep our users happy? That's why we're really here, right? I don't know. Some of you look dubious, but let's try it for today and see what happens. All right. So thank you very much. I will be here all day. I look forward to talking with you, and enjoy the conference.